Now I'd introduce our next speaker, who's Tomasz Bednarz. Tomasz is in computational sciences, imaging and visualization. He's an expert in these areas. He conducts research in the fields of these areas, including computer graphics and human-computer interactions, and he leads a project creating platforms for the big data analytics and visual analytics. So he's a project leader of the Big Data Analytics Visual Analytics project and a computational research scientist within CSIRO's User Centre, Computing and Services group in the visualization team. CSIRO is a partner investigator in the centre in ASIMS, and we very much value their participation. So I'll hand over now to Tomasz.
Take that one out. The clipper won't interface with your laptop, just because it's linked into our system, but you can still use it as a pointer, and you can stick that there if you want.
All right. All right. So I don't know why this one doesn't work. So I'm from CSIRO, yes. I'm actually from Digital Productivity Flagship. And I will be talking today about the journey of our project, which is called Platform for Big Data Analytics and Visual Analytics. And my talk in particular will be showcasing the ways how we execute the project. And as well, I will perhaps go a bit lower level as well and show you some basics of MapReduce and perhaps some other frameworks that are available on the market today, and how we are picking all these frameworks for our research. So I'm actually coming from Digital Productivity Flagship, as I said, and I'm as well a research team leader of Statistical Analytics and Inference Group. And those are a couple of projects that are listed that the group is involved in. So basically, we are considered as a bridge between theory and practice. So a couple of different scientific domains that we're trying to operate is listed here. So design, mixed modeling, disease models, big data analytics, graphs modeling, art and science, cybersecurity, and so on. And in particular, as well, I'm the leader of the project called Platform for Big Data Analytics and Visual Analytics. So what we're trying to do, we're trying to build up a unified platform for CSIRO researchers and scientists to leverage our infrastructure and as well compute and data capabilities so they can use them in their projects across the whole organization, so in some kind of unified way. So what we're trying to do, we're trying to support and foster community around big data processing, so trying to as well encourage people to use big data platforms and big data frameworks. We as well are building tools and services and that are supporting CSIRO-specific big data analytics needs. So if somebody has some problems, they can come to us and we can help them to run the problem on a larger scale, for instance. And basically what we're trying to solve the facilities, so software and hardware to provide to our scientists, and as well build up some portable VMs so people can run the software or build up solutions on the laptops, for instance, or on the cloud nodes, on Nectar Cloud, for instance, and so on, and they can build up the capabilities. So basically, to start off, I wanted to define what we understand as a platform. So we understand platform as a solution software stack on hardware infrastructure that supports development of big data analytics and visual analytics applications. And in particular, we're looking in 3 different areas. So the platform should be scalable, so you can have more hardware and be able to process more data, for instance. It should be universal, and basically we are closing our universe at the moment to the infrastructure we have at CSIRO, but as well we're very happy to collaborate with all of you guys. If you're interested, just come and talk to us, so we can perhaps connect and do something together. So in CSIRO we have lovely cloud infrastructure. We have as well HPC facilities. We have as well some special dedicated clusters, and we have as well one of the perhaps most famous in Australia, because it was the very first one in Australia, GPU cluster. And we have as well integration. It's one of our goals. So we're trying to integrate across all these clusters and services that are provided inside CSIRO. So perhaps one you should look at is Digital Access Portal, which allows you to store your data, large data sets, and share it with others, and as well cite your data set somewhere, for instance, in journal papers or your publications. And why are we doing that? Isn't big data problem solved already? So, we don't see it like that. Like industry is actually putting some kind of, like leading voice on that. But, like myself is coming from like physical background, from physics. So I can see, big data problem was always in science, right? So if you look evolution, for instance, of, physics research, you could see, the evolutions of the computer science and as well HPC and so on. So for us, CSIRO, so like again, I'm closing, this presentation to CSIRO context, but these slides actually are relevant to all of us. We are scientists, right? So we have to differentiate, science versus commercial. We have different needs, perhaps. We have very similar needs, and how we differ. In CSIRO, we cover many different disciplines and many different applications. We have different requirements. And we have as well diverse large-scale, storage facilities, for instance. So how we actually connect all this together when you have one data sitting on that cluster, another one sitting on the new one, which is just coming up. And as well, how we connect as well compute infrastructure. So how you talk from like GPU cluster, which is standard HPC cluster, and so on. So in the project, at the beginning, we try to understand what big data analytics means to science. So I'll show you in a couple of slides later how we concluded to it. We did like a bit of big data software surveys. We organized as well workshops around big data. So we did it like in last 3 years. Every year we had like a big data workshop. We did as well, like we have a lot of statisticians sitting on our side. So we did as well like survey on our big data packages. And as well in the project, we're trying to plan our platform. So we have like ongoing meetings, team meetings, and so on to define the platform and layered platform. And as well, design the way how we attack the problem, how we can combine actually like all those scientific areas together. So I will show you how we actually managed to do it. And as well, we're doing what we're trying to do as well, like questionnaires inside the organization, but perhaps it can go outside of organization as well. Again, understanding of how it is in science and scientists and CSIRO specific needs and tools and software landscape. So that will be on my next slides. So basically, starting with a big picture design. So we're trying, to see forest from the trees. So I'll show you what I mean on the next slide as well. So we're trying to define, layered version of the whole platform and making sure that it's portable, interoperable, and as well, in order to build a platform like that, you can't actually, you can build the most beautiful, technological, platform, but if you don't have use cases or people using it, it's useless, right? So basically building the platform, we're trying to talk to our scientists and build up, use cases and integrate the use cases into the platform step by step. So I showed that one as well. So what is that big data processing? Like many people understand it, in many different ways, and everybody, whoever you ask, will give you a different answer. So is it Hadoop? Is it like structured and unstructured data? Is it like GPU compute? Is it HPC compute? Is it SQL? Is it not non-SQL? And so on. So there are many answers, as many people. So I said it depends perhaps on the specific case you have, And if we go, like to Wikipedia, so Wikipedia explains big data as a collection of data sets so large and complex that it becomes difficult to process using traditional data processing applications. It's very simple, isn't it? So basically, industry is giving us some, direction. However, in science, we know it's more complex than that. And if you look as well, again, in the industry, everybody is talking about Hadoop, HDFS, NoSQL, and again, and again, and again. But many of the problems that actually industry is trying to solve as well is it's very similar, but as well we have some of the problems that we're trying to solve are completely different, and they may not match, like the simplicity that industry is using in terms of, simplicity of the frameworks or like the methods they're using. So for instance, like the streaming data from sensors may be very specific, getting data from domain-specific data cubes, and so on. So now we have to ask the questions, what we need, like to support really science in generic way, how we gonna connect all these dots together, how we integrate and get the most popular tools all together and solve everything together in the good way. So now analytics. Analytics coming from Wikipedia again, so this is like discovery of communication of meaningful patterns in data. And it's very broad, and we can see, that many tools that actually industry is using is as well, is coming from science, fortunately. So there's like a lot of statistical models, data modeling, machine learning, optimization algorithms, and so on that were already actually described during this workshop. And basically, like what we're trying to do, we're trying to understand who is really doing big data in the organization at this moment, and what are their needs. So we have like this special. So I will show you what's the process in the organization, how we tackling this problem, and what kind of problems they have, what kind of data processing algorithms they require, and whether they need prototypes versus productions, and so on, whether they're doing like the initial estimation of running basic stuff. So basically, like in our project, we're checking basically what is out there and how we can connect with our scientists and how everything fits together. So I show you, like in the next slides, we came to the conclusion after many meetings, how you actually do when you have different data sets. So you have data A, B, and C running on different infrastructures. 1, 2, 3, and as well 2 softwares and science application domains. So how you deal with the complexity. So basically what we did, we defined the forest and mapped the trees to the forest. So I'll show you how it is on the next slide. And pick up right trees to keep and use them. So the model is like this. When you have layered model, we have like the storage, data access and structure, compute, generic libraries and APIs, domain-specific services and libraries and applications. And those are consisted of like your domain-specific tools, or the tools that are available on the market, for instance, like open source tools that are amazing from many different companies, for instance, or coming from CSIRO itself. And then how we map this stuff to our infrastructure. So we have CSIRO-specific infrastructure challenges are coming here in data access and structure and storage, how you connect all these data servers or clusters together. Compute is the same, how you connect, for instance, HPC with GPU cluster, how you connect with cloud computing and everything in interoperable way. And as well, the application layers, when you have very specific functions and very specific, computational needs coming from different scientific domains. So how you gonna do it? So basically, we came with the list of the software packages that we're gonna be supporting our scientists, and we built up, this list of the tools. And then basically, depending on the use cases, we pick up some trees from the forest. And this way we can generalize the framework. And now depending on the use cases that are coming on the board, we can basically enhance the number of different software packages running in that layer. So our vision in the project is to build up some kind of data excellence center as a hub connecting different scientific domains. So what we have our platform is collaborating with many different divisions or flagships inside CSIRO, and we're trying to connect with many different people doing many different things. So for instance, image analysis, business analytics, visualization, logistics, astrophysics. And we're trying to bring the simplicity of the workflows to the scientists, and as well develop like this unified solutions, which is actually a very hard task, as you know, to build like something very general, but well, we're trying to do that. And we're trying to connect data analytics, simulation, statistical modeling, image and video analytics, machine learning into reusable stack of solutions, and build as well more interactive solutions, so going into more interactivity as well soon, and create new business cases, so get new grants and get the science evolving as well. So this diagram shows like the visual analytics diagrams that we use to explain some of our analytical models that we're trying to do. So we have some input data sets, And we have analytics models or analytics engines that are doing some data mining, for instance, that builds your knowledge for decision making. And we can do it, in the feedback loop. And then we can use as well visualization as something that is giving you some additional parameters to rebuild the analytical model to have better predictions, stuff like that. So I think most of you know about this kind of approach, and we're trying to be aware of this one too and making sure we're doing it as well. And success factors for us is, so we're trying to make the uptake of the technology inside CSIRO, but as well we're very open for the collaboration. So I'll show you a couple of frameworks that we developed that are available for public as well at the very end of this presentation. And we are trying to contribute to big data science globally, so we have a couple of successes there, enable new discoveries and reduce time to discovery as well. And this slide actually shows one of our previous projects that was executed on a Nectar Cloud. So if you go to cloudimaging.net.au, you can do image analysis in kind of workflow, so you connect different blocks of functionality together and create more complex algorithms and do image processing. So if you're interested, I can tell you a bit more about this later on, because this is not the topic of this presentation. So I can show you actually live demo as well, how it works. And my specific interest as well is in visual analytics, so I'm very much interested in data discovery and quantitative visualization as a powerful tool for us scientists to see the visuals, to extract some patterns from the data sets, as well to measure stuff from data sets, view of the data, as well we're doing stuff with videos and a bit of augmented reality. I have some PhD students working in this field. Immersive virtual reality and wearables as well getting more popular. And this example, for instance, shows the visualization that was done at NIST in States. So I was there for half a year last year, and what the guys were doing, they were doing simulations of the formation of the cement, having 10 different chemicals, and it was doing some numerical simulations. They couldn't speed it up. So basically what they did, they visualized stuff in 3D, but they did as well 2D visualization, connecting 3D graphics with 2D, very simple 3D graphics with 2D graphics, and seeing some patterns, they were able actually to subdivide the domains in the way they could put it on proper HPC cluster to have faster computations. And this one shows two of my colleagues that are inside the cave, 3D cave at NIST, and they basically operate on some data sets and interact with the data sets, measuring some and getting some extractions of the informations from the visualizations they have on the screen. And in particular, our project is oriented at providing incremental use case-driven development of technical capabilities. And basically how we work, we have a couple of phases in the project. So we have project initiation, so we have inception. So we talk about possible proposals with the different people, with different scientists. So scientists can come to us and ask us whether we can help them or propose or send us half a page or 1 page A4 of descriptions of the problem and whether they want to move the data pipeline, for instance, to big data platform. We use elaboration, so we talk inside the team how it should be done, and then we do construction and transition to the proper scientist that was asking for that. And we can do a couple of cycles as well. So we executed a couple of different use cases, so I will show them on the next slides as well. If you're one of the CSIRO collaborators, perhaps you have access to wiki page, so you can come to this wiki page and read a bit about how we do stuff and how we ask for the proposals. But you can as well talk to us, because we are very happy as well to collaborate with you guys. Big data cluster, that's something that was recently built as well as an experimental cluster. So it was funded by CAPEX, and what we have currently is tiny, really cluster. It's experimental for basically, testing all the big data frameworks. 16 nodes, 128 gigabytes RAM and 16 CPU cores on InfiniBand, and it's running in cloud, called Bowen Cloud, on Bowen Clouds. And it has capability of running different big data frameworks like Hadoop, Spark, and some other H2O, and so on. So if you're interested a bit more, you can go to this website and check it out. This is the architecture. So this is architecture which is sitting inside CSIRO, so perhaps I won't be explaining much about that. I'll just go to the next slide. And I wanted as well, because we're talking about big data, so I wanted as well to go a bit lower and say a bit more about the history of the big data as well, about the Hadoop. Everybody talks about Hadoop, but not many people knows really what it is when I talk to people. So I think, it's useful to have like this information as well at this kind of workshop. So it's basically a framework that allows us to distribute the processing of large data sets across the cluster, and it's designed to scale up. It came from Google, of course, and designed to detect and handle failures at application layer. So I will show you as well, how it is constructed. So it's basically constructed of two different layers. So like distributed computations and distributed storage. So like basically, we're talking about Apache Spark, which is being, more heavily used these days by everybody because it's much faster. And it's basically, HDFS is the system which you can run Spark on the top of it. So that's why I wanted to say a few words about that. And MapReduce is a paradigm that everybody perhaps know by now. And Hadoop handles different data types, so we know about that already. And wanted to emphasize, HDFS. So it basically breaks incoming files into blocks, and they split the blocks and are distributed among the nodes. And then the blocks basically are typically in 1 to 8 megabytes in size. And original data files not modified during life cycle. So that's just the basic stuff. And HDFS is optimized for large streaming reads of files. And basically, you have data replication. So it means, that chunks of your data are actually randomly spread across the cluster. So you have actually automatically built in, fault tolerance inside the Hadoop cluster. So this is showing, how it works. So you have, like, for instance, two files, data1 and data2, and those are divided into 3 blocks, and data2 is divided into 2 blocks, and you have data nodes. So you can see that chunks like 1 and 1 is distributed in different nodes than chunk 2, and 2 here. So in this way, you're getting fault tolerance. And this is showing like basic MapReduce example. So perhaps I won't be maybe saying much about this, but you have in MapReduce, you have 3 different phases. You have map, shuffle, and reduce. So you have, like, for instance, very basic text. You do mapping phase. Mapping basically reads each line and in the text and splits each word in separate string and allocate like 1 to every word that is in the text. Shuffle actually does the hashing of the records to reducers, and reducers are counting the number of words or repetitions of the words in the given text. So I wanted basically to have like this one defined, because later I'll show some examples of like how you do it in Spark, for instance. Then we have big data processing. We're talking about Hadoop is getting really slow, so it's not getting slow. I mean, you have better frameworks coming up, like Apache Spark, for instance, like which they claim it's like much faster, and it's much faster for the computations. But as well, like MapReduce is very simple parallel paradigm, and a lot of people, especially in modeling sciences, they have requirements of doing as well like iterative solutions. So there are like a lot of architectures, a lot of frameworks that allows you to do that. So we listed here a couple of different ones. So you have a couple of different ones you can use for, depending on your applications, of course, for doing like more iterative processings, not only very simple MapReduce stuff. And I wanted as well to talk about animals today a bit more. So animals, like basically I wanted to talk about Peak just to show you what kind of frameworks you can run on the top of Hadoop. And Peak is basically one of the frameworks developed on the top of Hadoop and allows you to run Hadoop jobs and MapReduce jobs that you don't need to worry about, and it's fully optimized. So they're saying Peaks eat everything. It means that Peak is swallowing any kind of data. So any kind of data formats you can imagine, it swallows the data. I'll show you how it works in a second. Peaks live anywhere, so basically it means that you can run Peak on your local machine, so you can download the framework and it works. It has pre-installed Hadoop installation, so you don't need to download anything else, just the Peak package from Apache website. Or it can actually live in the cluster environment, or can talk from your local machine directly to the cluster environment, like running Hadoop cluster. And pigs are domestic animals, so it means almost the same. So You can run it, on any kind of machine. And pigs can fly. It means, they can process your data very fast. And basically, it's an engine for executing data flows in parallel on the top of Hadoop. And it uses so-called pig Latin language for expressing data flows. And I will show a couple of features of that language quickly, just so you know. And as well, you can do a lot of operators that are included in the language. So you can do join sorts, filters for each groups, and so on and so on. And of course, it uses HDFS. That's why I'm talking about it here. And why to use pig? Because it gives you, productivity. So what you do in Hadoop, you can do 10 times faster in pig. The number of lines of code you have to write, it's really reduced. So it's very flexible. And you don't need to reinvent the wheel as well. So like 10 lines of pig Latin, it's like around 200 lines of Java. And workflow, how you do it. So you have like different statements in pig Latin. So you have like load statements, which will load your data. You have dump and store. And as well, pig is quite intelligent. So until you do like a dump or store statements, it won't do anything. So it won't make your clusters busy. And if it does, see the statement dump and store, it does start calculations. And in a nutshell, when you have your very simple script, what pig does, it parses the script, checks all the things that needs to be checked for proper like the execution planning, optimizes the code, and as well plans execution. So executes the command rather as a mapper or reducer, and submits all the jobs directly to Hadoop cluster, and as well monitors job progress. So it's very good. If you haven't tried it, just please try it. And perhaps it's data flow language, as I said, so describe how data is coming from one input and how it should be processed. So it has no if statements and so on, so I'll be going into details perhaps around this. But examples of how you can run it is you can run it in your terminal, for instance, in a local mode, so you can do very quick prototyping of your data before you put everything to fully scalable way on the Hadoop cluster, for instance. And you can use it as well in local, you can use it on your local machine and call directly, Hadoop cluster, which is actually quite powerful. And you can run it in interactive and batch way. And as well, you can use user-defined functions, so you can use your, for instance, existing Python scripts or Ruby scripts and so on. So data types that supporting, perhaps not important here, but what's nice is it supports schemas, so it gives you, flexibility of doing, calling different variables and defining, the data types they have. So this is like a very simple example I did, for our big data workshop a long time ago. Was like doing like the histogram of the rainfall coming from Bureau of Meteorology data sets. Have like data CVS, and then you did, like the schema. So you use like the code, station, year, month, day, rainfall, and so on. And then you could group the data by the rainfall, and you're getting the count. So you're getting basically the whole histogram of the rainfalls. So the commands, perhaps not important here, but this is like very simple word count example. Actually, I should show you as well, how you do exactly the same stuff in Hadoop. So you can see, like the 100 lines against, a couple of lines. So it's really perhaps, I can leave you the presentations if you're interested, so you can take a look later on as well in the code and more details. And I mentioned as well user-defined functions. So basically, if you have your codes, your like statistical, functions, methods written in Python, for instance, you can very easily add them to your code to pig scripts and call the functions. So for instance, this one is doing like displaying hello words, and this one is doing square functions. Just an example. And what we're teaching, our scientists how to use some big data frameworks. And perhaps for this audience, there are like a lot of libraries as well around this. So LinkedIn, for instance, released like Datafoo, which is kind of very nice statistical functions that you can use for executing stuff rather than you writing, mappers and reducers. You just use pig directly, and for page tracking, statistics, sampling, covariance, bug functions, and so on. And if you want to play a bit more, so this is like the last slide on pig. If you want to play a bit more how it works and how it digests different data formats, you can go to GitHub and you can download pick ABC toilets example. So basically what I did, I downloaded, like from ABC radio stations, the geographical location in one format of the data, showing location of the ABC station, state, and as well the geographical location. And as well, I did downloaded National Public Toilet Map. And what this example is doing is basically digesting, huge matrix and finding the closest toilet to the specific ABC radio station that you pick up. So you can go and play with that. It's not very long code, but it does amazing stuff. So you can fully scale it up. So you can imagine you can have huge data sets coming with the toilets or ABC stations or whatever else. And now, a couple of speakers already mentioned Spark. So I just wanted maybe to say a bit more to people who have no idea about that yet. So are there any people who never heard about Spark at all? Yeah, there are a couple of people, yes. So it's open sourced, and it's developed at UC Berkeley, and it's written in Scala, which is actually quite popular these days. And the key concept is that everything is executed in memory. So it gives you the speed up because of that, but as well bring the processing to data. So very similar model to what Hadoop does as well, and avoid data bottlenecks by distributing data when it is stored. And basically, the claims are that the efficiency improves like up to 100 times faster when you're doing computations. And as well, usability is, throughout different languages. So depending what kind of language you prefer, you can use Java, Scala, or Python to do your script writing. And basically, it gives you as well, less code to write. So it's actually quite useful. And I really strongly recommend you to look into that. Basically, the fundamental unit of Spark is RDD, which is Resilient Distributed Dataset. What it means, so if you go to the website, you can see it straight away. It's like resilient. If data is in memory is lost, it can be recreated. Distributed means that it's stored in memory across the cluster, so you have different cluster nodes. It distributes your data across the cluster. And data set can come from a file or be created programmatically. What else I should say here? So it supports like two different types of transformations and actions. So transformations are like maps, filters, group by, join, and flat map. So it goes like when you have base RDD, it creates another new RDD. And actions like count, collect, reduce, it gives you the value at the end. And as well, RDDs can hold different elements of different types as well. So it can be integer, characters, strings, or Java objects, or different mixed types. And if you haven't seen it before as well, that's very simple examples are running very simple, like the count in different languages, so Scala, Java, and Python. So everything is very similar to each other. You can see that you can get the data directly from HDFS, from your Hadoop cluster, for instance, and it's up to you, whichever you like to use. But perhaps, I would say most of the people are recommending to stick to Scala because it's written in Scala. And this was like example showing like the simple script, so I just go. So it was loading the data, getting some filters, so you can see how it looks, splitting the data into messages, and then counting the occurrences of who and bar. And some of our examples, so one of the use cases we had inside CSIRO, so it's like a project I think executed like a year ago. We had, if you have fish boats, they have cameras installed on the boats, and they observe the fishes that are taken, monitor the fishes, tuna fishes, and 24/7. And what we had video, and what we were asked to do was to speed up some of the algorithms that quantitative imaging group did on developing algorithms to extract only significant frames. Because like before, how it was, somebody was sitting in video and was counting the number of fishes, manually. So you could do it, in an automatic way. So using some computer vision algorithms, you can do it quite beautifully, and using Spark and connecting all these things together is even more awesome. So basically, like 30 days trip produces 720 hours of 180 gigabytes of video footage. And to process those data sets, it takes around 9 hours. So we developed Sparkle, so in the team, and the Sparkle was a prototype that was integrating Apache Spark with OpenCV, and it's actually done that perhaps you can run any kind of OpenCV. If you know OpenCV, you can run any of the OpenCV function with this framework. And the results, what we had, we as well developed like SPARK-HPC along the way, so I will show you one slide about that too. So processing or reduction of 256 videos of half gigs of size, and as well reduce the request. It was like, execution time was slightly reduced to 133 seconds. So, you can actually use this kind of frameworks to connect them together. So it's like, you build up like image RDDs, you do like the OpenCV functions that you execute directly in here, and then you're getting your output video files. So if you're interested to hear a bit more about that, just come and talk to us. We can tell you a bit more perhaps. And as well, one of my colleagues was working on large-scale genomic variation analysis. So we're basically testing or doing like initial testing of how Spark can handle, k-means and some statistical functions, clustering PCAs and visualization. So as well, it was like good testing, but so haven't used IPython ever. Just recommend you to use IPython as well, which is awesome tool for doing prototyping and as well doing visualization and seeing visually outputs of your computations. So this is one of the visualization coming from the processing. And as well, currently, we have collaborations with NIST going on, and this is like a very maybe strange example in terms of, like a big data, but it's coming to the big data, so you can imagine. So what we're doing, we're trying to use web browsers to visualize the surrounding environment, in kind of real time and do some, perhaps in the very near future, some data processing and some 3D annotations on the real-time environment. So you can imagine this kind of environments running in the mine site and, observing 360 degrees with the annotations if something is happening with that equipment, of that machinery, or something is not working well, of the sensor giving you some information that there's like a rock movement or stuff like that. So you need to use various, like the HPC facilities, big data processing connected with this stuff. So if you're interested in see some of this stuff running in live, you can come and visit us at CSIRO and Dayton Park. You're always welcome. And another example, it's actually like to show you how we do the work in the project. So we have like emergency situation awareness project, which was run by Mark Cameron and his people. So it's basically for digesting Twitter feeds and extracting some information from the Twitter feeds. So as far as I know, they were able to predict many different, like scenarios, like for instance, like the fires or earthquakes, in just 3 minutes, and help actually to make some action. So the whole project is actually used by many agencies inside Australia. And however, they don't have really like full capability for doing like real-time analytics yet. So basically, offline analysis for some of the data set they have, like 1.8 giga to generate online model currently takes 3 days. So you can imagine to create the statistical models, it's like forever. So basically, what we did, it's like one of my colleagues was working on this mainly, basically, prototype model and run it on Spark on our experimental Hadoop cluster, that we have inside the organization. And the same stuff, we could speed up like 15 times. So now, 1.8 artificially produced tweets can be done in 10 minutes. So going from 3 days to 10 minutes, it's a substantial speed up. And this slide shows SPARK-HPC. So that's the framework that was developed as well along the lines. So we have like a lot of HPC facilities inside the organization, and we wanted to run Spark on our HPC cluster, specifically on GPU cluster, to utilize the GPU power. So that was developed, and it's open source now, so you can go to this link and get it and use it on your HPC infrastructure if you have HPC cluster. it's open, and if you have any questions, you can talk to us. And inside CSIRO, we're actually now migrating to Slurm. So we have to actually redevelop it a bit to use Slurm, but this one runs on PBS file, PBS queuing system. So if you have PBS queuing system, you're ready to use it straight away. And one of the last slides I wanted to mention, we have first international symposium on big data visual analytics that will be happening in Hobart in Australia on 22nd to 25th September. So we have currently launched the website, and we have submissions open from today on. So if you're interested to come and talk about big data and visual analytics, it's the place to go. It's awesome city. If you haven't been, just join us there. And for even more discussions, if you're interested to talk to us, so we're happy to talk about big data and science, so how you connect this one, about how you solve your infrastructure and whether we can learn from each other, data provenance, of course, and how to link data centers together. Very much interested in data analytics, real-time data processing, and of course, upcoming Internet of Things, so everybody's talking about it. A lot of companies are doing a lot of stuff already, and we are interested as well. And as well, what's very important as well is communication. So I'm very much interested in art and science, connecting dots together, how you explain your complex science to general audience, not to, like domain experts only. And as well, what I should mention, GPU, like I'm saying, NVIDIA released like a blog post about, Spark and GPUs. So if you're going to GTC in California, they're gonna be talking a bit more about the big data machine learning platforms, using Spark and GPU clusters. So they're saying you can even have, with Spark, you have huge speedups compared to Hadoop, but if you use GPUs, you get even 10 times more, depending, of course, on the application. So thanks a lot. That's it from me.